this video I'm going to show a couple things. I'm going to fabricate a couple of different parts here that have different purposes, but I'm going to kind of make it one effort since I'm using some sheet metal and I got all my tools out, and it kind of similar fabrication using the aluminum sheet metal here. So I'll show you what I've got just to start with. It's kind of a standard stock of tools that I'm going to use here. Basically a file, a nut riveter and shears, a little smaller file here, screwdriver, just basic stuff, my assorted nut inserts, and then some stock aluminum here, hole drill, this guy here. I love these little things, they're really good. Got it at Harbor Freight. It's very inexpensive, but I'll tell you, it goes through this stuff very, very easy, very nice. And of course my drill. To start with is my fuel shutoff. This is the main valve that controls fuel flow from the cockpit area, and you have the opportunity as the pilot then to turn your fuel on and off. So this is a really nice one, commonly used. It's a Newton or NC valve system. Now this one here will work with two different input sources, and you can control them, one being on or off, or both being on or off, which the little things cover. But you see this is an on or just an on. I don't see that it matters for me because I just have one fuel source coming in, so for me it's an on and an off. I don't have dual tanks. So as part of fabricating the seat pan here, that fuel valve will go right here, just sort of below the leg of the pilot, and you can see I've roughed out basically the opening here where the backside of the fuel valve will poke through, and then I've rough drilled or spot drilled these holes here that line up with the mounting flange on the front side. Now what I'm trying to achieve here is, I can't really show you the back of this, but behind this system, what it needs is something to bolt to back here, and what I'm making for that is a nut plate that fits the assembly, and I'm going to cut that out of the metal, the aluminum, and then fabricate that to the proper size and such, and make that to where then that nut plate will go in behind that, and it'll give this valve something to screw onto. So first things first here was to take the shears. I measured out, I'll show you the finished product here, but I measured out from the stock the dimension that I needed, and cut it out, and then use the this hole drill bit to get a hole in there that's dimensional for the valve itself. Then of course you have to line up the holes and mark those on the plate and so on. Once you get that kind of configuration set up, then you're ready to go in and drill for the nut inserts, which this happens to be a 632, which is appropriate for what I'm doing here. And this then will take the basically the sort of countersunk number 6. This is a stainless, and it'll seat down in that pocket. I don't know how well you can see that really, but it'll sit down in there, and these all just kind of work together. So this is what you're shooting for. It's kind of what you end up with here, and it makes for a nice firm attachment base behind that fiberglass seat pan. This will just give you a proper amount of reinforcement for that, because you are going to be you know, the valve moves easily, but you want to have that extra stability so that you don't alter or wear out, say, the bolt holes or something for the mounting bracket. So anyway, I think this will work just fine. So we'll look at it here in a second after I install it. Here we are with the front portion of the valve assembly mounted. This is the mounting flange. And what we're doing here is trying to, of course, get it flush to the seat pan, which you can see that it is. It's not wonky. And then I'll try to get under here where you can see See the nut, the plate there, maybe it's better up this way, and you can see what I ended up with here. Well, here you go. This is what you're after, and of course the valve just spins, and very accessible while sitting in the seat. You know, you literally just comfortably reach down and turn that valve as part of your startup procedure. So now I'm on to my next project, and I'll show you what that is. One of the things to consider when you're building this is, of course, the electrical system is pretty full on. I mean, there's a lot to learn, a lot to know there. I've corresponded with different Helicycle owners and the factory owner and people to try to get onto what has been time tested and what's good and right and so on. One of the things that's recommended, and not all Helicycle pilots do this, or builders rather, is isolating one battery from another battery. So the start mechanism of the turbine engine has a lot of draw on the battery. It takes a lot of oomph to get that going. But the rest of the system suffers as a result of that heavy draw off of that battery while you're trying to start this. So one technique is then to isolate a battery from the main battery that will help run some of the electronics or instruments and other features of the start process. So the question is, well, how do you do that, and how should that work? And I'm kind of learning that now, so I'm building this into the system. And one of the questions that comes up is, when you isolate a battery like that, how do you know the battery's charged? How can you check it to ensure that it's properly, that's giving you what you need on the output side? And also then that battery has to also be charged. So I won't go into the details of how the schematics talk about that, but I'm going to isolate this battery, but I'm also going to isolate a method by which I can check that battery pre-flight to make sure it is charged, and also to have a charging port built on so that when this is not in flight, you can just hook this to a trickle charge system, and that battery then will stay charged. So let me kind of show you where this is all headed. I'll show you this instrument pod now. So basically, the instrument pod as such, I've been playing with my radio, and I've been also messing with getting some of the infrastructure built out for how the wiring harness and everything's going to sit in there. And the battery, the isolated battery for me, is going to sit back in there. And it'll have an access port on this side of the pod. And the thing that I'm going to fabricate now will be on this side of the pod, and it will sit somewhere around here. I probably won't cut this in anytime soon, but I do want to go ahead and build and test my little meter to see that it works and make sure that it looks good. So I'm going to be using the same setup here, the same stock materials and tools. That's why I'm doing these together, because I've already got everything out for it. So hang tight, and I'll get back and show you what I did. Alright, here's that battery that I'm talking about. It's just a small motorcycle style 12-volt battery. It's got a nice punch to it. And remember then, the question was, how do we know how much that battery has, right? Pre-flight, we want to know, is it charged up fully? And so this is what I built. Now remember, this will get mounted onto the side of that instrument pod. And so what you have here then is a little momentary switch that I'll demonstrate for you. So pre-flight, you can come in and you can push this switch, it'll light up, and it's going to tell you how many volts are sitting in that battery. And obviously we want it to be fully charged, as this one is. When this battery is not being used, when the Helicycle is not flying, you want to ensure that you can charge it. So here's your charging port, and it accommodates these two-prong trickle charge. That's kind of a standard, industry standard thing here this junction plug is. And that plug will ultimately just be put just like you see, red hot, black to ground on the battery post, the terminals that I have built into this thing. So this is what I envision as working for me. I think it's going to be a good system, should be pretty reliable. I, by the way, check this gauge accuracy against some other equipment that I have, and so far it's spot on. It seems to do a really good job. And this is of course a very compact thing. You can just mount it there onto the side of that, and it doesn't take up a lot of depth. As you can see, the back end of this is shallow in the sense that it doesn't have a lot of deep fitting protrusions, so you'll get all the clearance you need without any real problems here. So these are the two things that I fabricated today just out of the stock materials, and using a little bit of my own imagination about how I would like to see this work, which is really one of the good things about the Helicycle building it. You get to customize a lot of things, and you know that you want, the way you want to see it.